Okay, this is problem number 10 on chapter 8, section 1. In this problem, where we are going to test a claim using the critical value method. It's a little bit different than the one we did in the previous videos and the previous exercises. In this problem, they provide with the test statistic right here, and they test the claim that well, we want to test the claim that the population proportion is less than 0.76. Okay, so it says using a significance level of 0.01, find the critical value or values. So this is the definition of the critical value. A critical value is a score, a point here on the number line that separates the critical region where we reject the null hypothesis from the values of the test statistic that do not lead to rejection of the null hypothesis. So basically alpha, which in this case is 0.01, determines the critical value. We know it's a left tail because the inequality is pointing to the left, is less than. So we know that this is a left tail. And alpha represents that area which is on the left tail, this shaded part. Alpha represents area. Okay, and what you want to find here is that z-score. So this is the z-score we want to find. So we have area and we want the z-score, and that z-score will separate this area of fail to reject the null hypothesis from the rejection zone. Okay, so first of all, I need to find that critical value. So I have area and I want the z-score. What I use is inverse norm on the calculator. Whenever you have area, we use inverse norm. Let's press second vars, and let's go to number 3. The area is 0.01. Since the area is on the left of this score, we don't need to subtract from 1, so we just type it like that. In the calculator, you need to type area on the left side of that z-score. We keep the mean and the standard deviation as 0 and 1. We paste that in the main screen, and that is the z-score you will obtain, negative 2.33. Okay, that one right here. So let's see, negative 2.33. Let me write this part again. So so this critical value determines if you reject the null hypothesis or fail to reject. And you have to compare the test statistics, the negative 1.87, which is basically falling maybe right here. The test statistic, let me write like a little t on the bottom to identify that this is the test statistic, negative 1.87. And you can see that this number, negative 1.87, is falling here on the white area, which is the part where you failed to reject. Okay, so we failed to reject the null hypothesis. Okay, it's going to be either this option or this option. Okay. And notice that this test is a test by position. This number, the critical value, is the benchmark. We could say that is a benchmark. If your test statistic falls anywhere to the left of this value, we would reject the null hypothesis. But if it falls on the right side, we fail to reject. So let me write the null hypothesis. Actually, I should have done this from the very beginning. The null hypothesis is P is equals to 0.76. Remember, the null hypothesis only admits equality. It's a mathematical statement, and the alternative hypothesis in this case is less than 0.76, and the claim is on the alternative hypothesis. Okay, so the claim does not include equality, and you reject the null hypothesis. No, this is not our case. We did fail to reject. Let me write here the null hypothesis. Sorry, I missed that. And it says original claim does not include equality. Yes, is our situation, and you fail to reject. Yes, that is the one I have here. Okay, so that's how you write the conclusion. There is not sufficient evidence to support the claim that P is less than 0.76. Okay, so is this option right here. There is not, no, I'm sorry, the option right here. There is not sufficient evidence to support the claim that the population proportion is less than 0.76. Okay, so that's how you do this problem.